So as you can imagine, drawing these electron transfer diagrams every single time to figure out the formula of an ionic compound would get pretty time consuming and a little bit exhausting. So I'm going to show you a faster way to figure it out. So we know that everything in group 1 has one valence electron, right? So they're always going to lose one electron to form an ion with a charge of +1. So everything in group 1 will have a charge of +1. Likewise, everything in group 2 will have a charge of +2. Okay? Looking over at the nonmetals, everything in group 17 needs to gain one electron, so it'll be -1. Everything in group 16 needs to gain 2, so it'll be -2, and everything in group 15 needs to gain 3. Okay? So this is how we can easily figure out their charges. We'll spend a lot more time on that in the discussion, but that's just kind of a preview. So if I know the charges of the ion, I can figure out the ratio of the ions that are going to need to go together to form a neutral compound. So let's look at the example of potassium, which forms a +1 charge. And when it's positive or -1, you can just put the charge, the 1 is implied, you don't have to show it. And let's say I was going to combine that with fluorine. Okay? Now, I have to ask myself, how many of each of these ions do I need to form a neutral compound? Well, this is +1 and this is -1, so they balance each other out. So I just need one of these and one of these. So I would write the formula as KF. Again, I don't need to put ones here because the 1 is implied. Now, what if, though, I was combining potassium with oxygen, which has a -2 charge? Okay, well, now, one potassium and one oxygen do not balance each other out, right? Because this is -2. So I have to ask myself, how many potassiums would I need to balance out that one oxygen? Well, I would need 2, wouldn't I? Because that gives me +1 +2, and that balances out the -2. So since I'd need 2 potassiums and 1 oxygen, my formula would be K2O. And that little subscript there tells me that I have 2 of the potassium ions. Okay? Let's look at a few more examples. Let's say I was going to react barium, which has a +2 charge, and oxygen, again, which has a -2 charge. Again, these balance each other out, +2 and -2. So I just need one of each, BaO. But what if I was going to react barium with nitrogen? Now this is a little bit trickier, right? Because these don't balance each other out. Okay, so let's add another barium. All right, now this is +4 and -3. It still doesn't balance out, but it's a little bit too positive, so I'm going to add another nitrogen. Now it's +4 and -6. So it's a little too negative, so I'll add another barium. So now I have +6 from all those barium ions and -6 from the 2 nitride ions. So that does balance out. So you kind of have to keep adding ions to each side until you get them to equal out. So I use 3 bariums and 2 nitrogens. So my formula would be Ba3, because I used 3 bariums, N2. Okay? I want you to try to see if you can figure out how many of each you would need for the different combinations that I'm going to give you.